And then we have our new special right triangle. Friday we had 45, 45, 90. What's the missing angle here for me? Missing angle in your first diagram. I gave you a 90 and a 60. Lauren, what's the missing angle? Oh, I gave you a 90 and a 30, but now I told you.
What?
What's the missing angle? 60, yeah. Right, because it has to add up to 180. Here's your new right triangle. 30, 60, 90. 30, 60, 90. We had 45, 45, 90 on Friday. 30, 60, 90 triangle. All right, so instead of investigating like we did on Friday, I'm just going to give you the conclusions because we got to practice today. So in a 30, 60, 90 triangle. All right, before we go to conclusions, I want to name the three sides. All right, name the three sides. We had legs and hypotenuse on Friday. Well, guess what? This ain't going to change. The side across from the right angle still called my side across from the right angle. Shar, that's my hypotenuse. That's never changing. That's always the side across from the right angle. All right, but now I got a little problem. All right. Yes, the other two sides are still legs, but are they equal today? No, right? Because they're across from two different angle measurements. So I just can't call them legs anymore. I need to attach something a little extra. So here's what I'm going to attach. One is the shorter leg, and the other is going to be the longer leg. How can you figure out where they're located? You already know. You already know from something we did earlier in the year. In a triangle, where's the longer side always located? Across from what? The bigger angle. So at a 30 and 60, which one's my bigger angle? 60, so guess what's across from it? Your longer leg. All right, so wherever the 60 is, across from it's going to be, we're going to call that the longer leg. I just can't say leg anymore. All right, I just can't say leg. I got to say longer leg. And across from the 30, wherever the 30 is, we're going to call that the shorter leg. Just be aware it may not be in the position of this diagram. I may switch the 30 and 60, so the shorter and longer leg get switched. All right, longer is across from the 60, shorter across from the 30. All good. It's already starting to get more involved, right, than Friday? All right, so go back down to our conclusions here. Two conclusions in a 30, 60, 90. The first one's going to be how to find the hypotenuse in a 30, 60, 90. This one's the easier one, I think. The hypotenuse, you double the shorter leg. So 2 times shorter leg. Whatever the shorter leg is, you double it, and you got the hypotenuse length. You have the hypotenuse when you double the shorter leg. And the second and final one in a 30, 60, 90 is how to find the longer leg, the one across from 60. The longer leg. I take my shorter leg, whatever the shorter one is across from 30, and you multiply it. Here's where it might get tough from Friday. You got to keep them separate from what we did Friday. You multiply the shorter leg, ready, by the square root, radical 3. Radical 3. Remember what we did on Friday? It was radical 2. Keep that with the 45, 45, 90. All right, radical 3 is with the 30, 60, 90. So there are the two conclusions about the sides of the 30, 60, 90. All right, we ready? All right, let's grind out a few problems. I'll let you do a couple in your groups when I think we're good. All right, first one, we see that's a 30, 60, 90. Plot my 30 in here. First thing I want to know from somebody, what is the 12 I gave you? What's that side called in the 30, 60, 90? That 12 I have given you. That's the what? Stephanie, back to you. All right, hypotenuse. So I want you to do exactly what we did on Friday. Oh, I'm given the hypotenuse. Let's write the hypotenuse rule for a 30, 60, 90. The hypotenuse is equal to, now remember, this is a 30, 60, 90, right? Not a 45, 45. Hypotenuse 2 times, I'm going to start abbreviating, SL, shorter leg. 2 times shorter leg. So whatever you're given, write the rule. Now substitute. 12 substituted in for the hypotenuse, and now we have enough information to tell me what the heck the shorter leg is. So hopefully you can solve that for the shorter leg. If you want to put an X there, a Y, go ahead, instead of SL. All right, knowing the hypotenuse is 12, how about my shorter leg? How long is the shorter leg now? Shorter leg, where am I going here? Finley. 6, good. So shorter leg is 6. Across from the 30, that's got to be 6. It did say find all sides, so now we have to find the longer leg. Good thing we have a rule for the longer leg. So longer leg, I'm going to abbreviate LL equals shorter leg. Be careful, square root of 3. Square root of 3. What are we plugging in for shorter leg here? We just found it, but what are we plugging in for the shorter leg? Vinny?
6.
Yep. So longer leg, there's nothing to do here because I don't want any decimals. 6 square root of 3. And there's my longer leg. Whatever you're given, write the rule down. Everyone's all good so far? All right, ready for 2? What's the 8? What did I give you? What side is the 8 that I just gave you? There we go, on fire today. Shara? Nope, sorry. Finley, back to you. I gave you the shorter leg. So if I give you the shorter leg, you guys got free reign now. You know how to find the hypotenuse and you know how to find the longer leg. It's just a matter of what your choice is. So what is your choice? What do you want to find first? Because there is no wrong answer here. Not here. 13, Jonathan, what do you want to find? Sure, here we go. Hypotenuse. The rule is 2 times shorter leg. Substitute in that shorter leg. And then how long is the hypotenuse? Stephanie? 16, yep. I got 16, good. All right, now find your longer leg. Longer leg equals shorter leg times radical 3. Substitute in 8. Radical 3. Before we move on, quick comment. Let's just say you found 2 sides and you're ready to find the third, but Wednesday you totally freeze and blank on the rule. Is there still a way I can get to the third side without remembering the rule? What could I use? If I know 2 sides, let's say I know 8 and 16, but I totally blank on the longer leg rule. There's still a way? What is it? Yeah, Pythagorean theorem. Okay, so keep that in your back pocket. If you know 2 out of 3 and you blank on the rule, you can still use Pythag. Hey, lock in real quick. This may happen to you, and I haven't mentioned it yet. If you do Pythag and you have radicals involved, so let's say you did 8 squared plus, and now you're ready to plug in 8 radical 3. Put that bad boy in parentheses in your calculator. Because if you do this without the parentheses, what's your calculator thinking you're squaring? Radical 3. All right, we want to square the whole thing. So if you use Pythag with radicals, make sure it goes in parentheses, please. It's just a calculator thing. All right. Okay, 2 more together, and I'll let you do the last 2 on your own. What's given here now? What's that 2 radical 3? What were we given? We're only working with certain people here today, huh? Henry, what was the 2 radical 3? That's the shorter. Perfect. Find whatever you want now. All right, because both rules involve the shorter leg. So your pick. What do you want to find first? Hypotenuse or longer leg? Stella? Hypotenuse it is. Hypotenuse is going to be 2 times that shorter leg. And once you know the rules, I don't expect you to write them out. I just write them out so you can see where everything's coming from. So hypotenuse is going to be 2 times that 2 radical 3 I gave you. And good thing we got the calculators now. And what's the hypotenuse looking like here? 2, 4. It's always the suspense until I find. There we go. Tess. 4 radical 3. Thank you. All right, now we go longer leg. And again, you freeze on the longer leg. Oh, boy, was it radical 3? Was it radical 2? Do Pythag. right? But make sure you put those radicals in parentheses. All right, but if we are finding the longer leg using the rule, it is shorter leg times radical 3. So whether you use that rule or Pythagorean theorem, still get you there. So 2 radical 3, shorter leg, times radical 3. Good work. Keep it going. What's my longer leg for this one? Longer leg. Let's see. Bryson?
3 radical 6.
What are you multiplying here? Or how are you finding the longer leg?
It's the short leg times.
So 2 radical 3 times radical 3, right?
Yeah.
I don't know how you got 3 radical whatever. You might want to use your calc again.
Oh, it's 6.
It is 6. Yep. We all good? Hopefully you can use your calculator on Wednesday there because you're not going to have help from your group. Ready for 4? Okay, what did I give you in 4? What did I give you in 4? Ones. Makai, what did I give you in 4? Okay, you got no choice now. You got to write the hypotenuse rule. The only time you got a choice is when I know the shorter leg. So hypotenuse equals shorter leg times radical 2. Substitute in 6 radical 2. And now from Friday's discussion, how do I get the radical 2 out of there? It was radical 3, right? Okay, no one's going to stop me here. I'm totally off my game and rattled right now. How about we do this? 2 times the shorter leg. How about that? One job. One job. Here we go now. 6 radical 2. All right, now how do I get rid of the 2 here? How do I get rid of the 2? Drew, I want to solve for the shorter leg. How to get rid of the 2?
Divided by 2?
Yeah, divide both sides by 2. Take 6 radical 2 in your calculator, divide it by 2. How about the shorter leg for this one? Shorter leg. Go ahead, Tess. 3 radical 2. Good. So that's across from the 30. Now you can do Pythag or find the longer leg yourself using the rule. All right. We can use Pythag or we can use the longer leg rule. I don't care how you get there. Your choice. You can take the shorter leg and multiply it by radical 3, or you can do Pythagorean theorem with parentheses. When you have it, let me know. Longer leg of this problem. Here. There we go. Dylan. 3 radical 6, longer leg. Good. All right. You and your group or by yourself, whatever you prefer. Next 2 on your own. Please do not go on to the third problem, though. Next 2 triangles on your own. Find the missing sides. Find the missing sides on your own. Or with the group. Just don't move on to the last problem for me. So 5 and 6 only. 5 and 6 only. Once you find one side, you can do Pythag now to find the last one. All right, looks like we can move on here. Good. I'm glad you guys are picking this up. Because I got to challenge you here on number 7. All right, shorter leg. You were given the longer leg, so you were forced to find the shorter leg first, not the hypotenuse. So how about the shorter leg here? Shorter leg. Bailey?
Sorry.
Number 5, shorter leg.
6.
6, yep. And if the shorter leg 6, that makes the hypotenuse in this one. Henry? 12, yep, double it. Any issues? All right, and finally over here, longer leg's 12, so how about the shorter leg? Stephanie?
4 radical 3.
4 radical 3, yep. And then how about the hypotenuse for this one? 9, Vinny? Double it, 8 radical 3. Any issues? Because now you're going to get challenged a little bit. All right, now what I want to start doing is, all right, let's put 2 triangles in one diagram. And you're going to see maybe one of them's a 30-60 and maybe another one's a 30-60. Or maybe another one's a 45-45-90. First thing I need your help with, though, as you can see, A through E is find the missing angles. Find the missing angles. So we can figure out where the special right triangles are. So DCB, go ahead, DCB. You already know 2 out of 3. All right, one's 60, one's 90. What's DCB? Let's roll through these, a couple of them anyway. Bryson, what's DCB?
30.
30, everyone. Make sure you fill it in your diagram, too. So you can look up. Everyone see a 30, 60, 90 right off the bat. All right, we'll get back to it. We got more angles to find, though. CDA, the one right next to 60. CDA, ones. Micaiah, what do you got there? $1.20, good work. Supplementary with the 60. All right, let me slow down now. DCA. Take a look at triangle DCA. What type is it? Isosceles. What's across from those congruent sides? All right, now we know how to find the angles. All right, I have an angle of 120 already, and I know the other 2 are congruent to each other because it's isosceles. And what are those other 2 angles here? Those other 2 angles, Finley? 30 and 30. Yep. 30, 30. That answers the next 2 parts for C and D. 30, 30. And now in part E, it wants me to combine angles. So ACB. How many degrees in ACB? Brendan?
60.
60. All right, we all good with the angles. Any issues finding them? Now look at the diagram. Before we start answering F through J, look at the diagram. Do you see 2 30, 60, 90s? I see a 30, 60, 90 right here for DCB. And everyone else see the other 30, 60, 90, the big one. A, B, C, right? 30, 60 for angle C, and B is the 90. So there's 2 30, 60, 90s. Work with one at a time. Don't bounce back and forth. So I want to work with triangle DCB. Also, guys, I don't even care what this asks right here. I'm just going to find all the sides I can using my rules. And then I'll go back and answer the questions. All right, I don't, you want me to find DC? Sure, I'll find it eventually, I'm sure. So let's help me start in triangle DCB. Start in that 30, 60, 90 triangle and help me find some sides. I notice they gave me a side of 5. Is that the shorter, longer leg, or the hypotenuse in that 30, 60, 90, the 5? Only look at that triangle. That's it. What's the 5? What's the 5 in that one? Zoli?
The 5 in
Triangle DCB. It's the shorter leg. All right, perfect. Now you can find both sides. You can find the longer leg, the side across from 60, and the hypotenuse. All right, so first I want longer leg. What is the longer leg in that triangle DCB? The longer leg. Shorter leg was 5. Use your rules. What was the longer leg? 4, Tess? 5 radical 3. So everyone see, across from the 60 is 5 radical 3, which is CB. All right, you just solved for CB, 5 radical 3. What's the hypotenuse in that triangle? I know 2 sides, so if you want to do Pythag, you can, but let's get right to it. What's the hypotenuse in that 30, 60, 90? Use your shorter leg of 5 to get there. Stellan? 10, which is DC. So DC 10. All good. All I did was focus on that right triangle only. All right, now we'll keep going. Next thing they asked me for is DA. Don't overthink this. Don't try to use a rule either. I can't use a rule. Why? I can't use a rule. AD, is that part of any of the two triangles that we said were special right triangles? No, right? It's part of ADC, which I have no idea. I've never heard of that triangle before, a 30, 30, 120. I don't have rules for that. But we knew at the beginning DA and DC were congruent, didn't we? So if that one was 10, got to be 10, right? That's why I put, don't overthink it. It's not part of a special triangle, so I can't use a rule. All right, ready for the big dog now. ABC. That's a 30, 60, 90. That is a 30, 60, 90. I'm going to ask somebody, what side length do you already know in that 30, 60, 90? What, that 30, 60, 90, which is triangle ABC. What side or sides do we already know? Your call. Take anything here. I'll take anything. Simon? What side do we already know in that 30, 60, 90 ABC?
AB.
AB, which is 15. All right, we got AB, 15. You just gave me what? The longer leg or the shorter leg?
Longer leg.
Longer leg. I'm still looking for AC, right? Which is the what in the diagram? That's the hypotenuse. So I know my rule is hypotenuse equals 2 times shorter leg. Simon already admitted he gave me 15 was the longer leg. So where's the shorter leg then? I don't want to plug in 15. That's the longer one. Where's the shorter leg on this diagram? Whew, look at that. 15, 15, right? Lexi, where's the shorter leg? 5, radical 3, because it's across from the 30. So 2 times 5, radical 3 will give you the hypotenuse. So let's finish this one off. 2 times 5, radical 3. Or if you did Pythag to find it, you can do that too. Stellan, finish off. 10 radical 3. Watch out for these diagrams. They're tricky. But stay in one triangle only. All right, stay in one special triangle only. You're on your own now. Let's get rolling.